Hello and greetings to Prof. Devarajan. I am from Group 5. This is my group member. My name is Fazrul Hassani bin Kamarul Zaman. Matric number MH19058. I am presenting a BMA 4513 Energy Efficient Vehicle for Assignment 1. Now, I begin with National Automotive Policy 2020, which is NAP. The National Automotive Policy, which was introduced on 21st February 2020. The aim is to advance the automotive sector in the era of digital industrial transformation by concentrating on next generation vehicles, industrial revolution, and mobility as a service, to position Malaysia as a regional leader in manufacturing, engineering, and technology. The NAP 2020 is an improvement over the NAP 2014, which was centered on making Malaysia the center for energy efficient vehicles through the development of research and development capabilities for right-hand drive cars and related technologies like fuel efficiency, light materials, telematics, tooling, and component design. Next, I will continue to vision of NAP 2020. Number 1 is supply chain integration, which is establishing manufacturing facilities for automotive vehicles, parts and components, as well as using Malaysia as a center for increasing manufacturing production. Number 2, local manufacturing, which is increase local production of automobiles and parts and support remanufacturing. Number 3, engineering capabilities, which is improve local engineering R&D, testing and technology development capabilities. Number 4, latest technology trend, which is utilize IR 4.0 technologies to adopt and acclimate to the newest technological trend. And lastly is sustainable development, which is utilizing environmentally friendly products and process that minimize carbon emissions will help the automotive sector develop sustainably. Next is objective of NAP 2020. Number 1 is develop a NXGV technological ecosystem to make Malaysia the primary NXGV production hub in the region. Number 2, increase the MAS sector's involvement in the automotive industry, which is mobility as service. Number 3, make sure the local automotive industry is prepared with a new paradigm that is closely tied to the development of IR 4.0. Number 4, ensure that the deployment of NXGV has a positive impact on the entire ecosystem. And lastly is, by 2025, Malaysia will lower vehicle carbon emissions by increasing fuel economy. Now, I will continue to new elements in NAP 2020, which is Next Generation Vehicles NXGV, which is categorized as a vehicle that satisfies the criteria for EEV classification and has been augmented with intelligent mobility apps that have at least level 3 vehicle automation or conditional automation. There are 5 layers of autonomous, automated, and connected vehicle technology used in SXGV vehicles. Second is mobility as a service. Mobility as a service is a concept designed to combine numerous service kinds and transportation options into a centralized, which is effective mobility solution. Lastly is industrial revolution, IR 4.0, which refers to the application of digital technology beyond the technological elements under Industry 4WRD. These new elements in NAP are in line with the advancement of future technologies, which is improve the current NAP. Next, I will pass to other presenter. Thank you.
Hi, my name is Muhammad Hasmi, Development MH19055, and I will present about what is EV and EEV. What is EV? EV is a shorter acronym for an electric vehicle. EVs are vehicles that are either partially or fully powered on electric power, and EEV is an acronym for an energy efficient vehicle. It is a form of green transportation that minimizes carbon dioxide emission and eliminate reliance on fossil fuels. EV are vehicles that meet set of defined specification in terms of carbon emission level and fuel consumption. There are 4 types of EV. First one is a battery electric vehicle, BEV. It's a fully powered by electricity. These are more efficient compared to a hybrid and plug-in hybrid. Example in Malaysia you can find is a Nissan Leaf and Tesla Roadster. Second one, hybrid electric vehicle (HEV). These vehicles use both the internal combustion, usually petrol engine, and the battery powered motor. The petrol engine is supposed to drive and charge when the battery is empty. These vehicles are not as efficient as fully electric plug-in hybrid. Example you can find in Malaysia is Toyota Prius and Honda Jazz. The third one, plug-in hybrid electric vehicle (PHEV). This vehicle uses both an internal combustion engine and a battery charge from an external socket. This means that this vehicle battery can be charged with electricity rather than the engine. PHEV are more efficient than PHEV, but less efficient than BEV. The example is a BMW 3 Series E330E, and the last one is fuel cell electric vehicle. The price of EVs, especially HEV, PHEV and BEV is high because of massive research and development spending, and the battery pack is high production cost. Because of EVs will reduce only through continuous technological processes. The incentive to support progressing of Malaysia's relevant technologies, and some of the stimuli and policies are listed below. Okay, the first one is a 10-year 100% pioneer status and 5-year 100% investment tax allowance for the production of highly critical or value-added components. Second one, soft loan for tools, dies and bulk manufacturers to develop new tooling as it can be expensive. The third one is a provision for loans to be grabbed by product and spare part suppliers to improve their productivity and by strengthening their operation, including management and technical cooperation. And the last one is the subsidy to support the research, development, and commercialization of biofuel technology.
Assalamualaikum and hi, my name is Falik bin Muhammad Nisham and I will continue present. Okay, so how does EV and EEV relate? Okay, so before we relate this EV and EEV, we need to understand what is the definition of EV and EEV. So as you can see here, Tesla is an electric vehicle, so we know it's a efficient vehicle. But Axia is a petrol-based vehicle, but it is an energy efficient vehicle. It is an EV. So how does these two relate? So let's continue to understand the definition of EV and EEV. So EV stands for electric vehicles, and electric vehicles is vehicles that use electricity to propel the car. Electric vehicles can have its power from extra vehicle source, collector system, and battery, which is the most commonly used for electric vehicles as of now. So what are the electric vehicles? Electric vehicles includes but not limited to cars, surface and underwater craft, electric aeroplane, electric spaceship, rails, and so on. So this is an electric vehicle. This is the definition of electric vehicle where it uses electric, no matter where the power source is, to propel the car, to propel the vehicle. Okay, so let's move on to EEV. So what is EEV? EEV stands for energy efficient vehicles, where it is efficient in using the energy, like that. It has a standard requirement from NAP, National Automotive Policy, with at its fuel usage and carbon emission level. So EEV include hybrid car, include electric car. So this is EEV, energy efficient vehicle. So so how does EV and EEV relate? So basically, an EEV cars have a limited or meet the specification of the carbon emission limit by NAP and the fuel consumption limit by NAP, of course. While the electric vehicles, as we know, electric vehicle produce no carbon emission and use no fuel consumption, as it actually use electric to move its car. So this is how an EV and EEV vehicles are closely related, because the EV, electric vehicles car, have met the requirement of the energy efficient vehicle. So thank you. That's all from me.
Hello, my name is Chalindiran Ramana, metric number MH19052. I will continue with my part of the presentation. That is the car we have chosen to better the energy efficient level, which is Proton Saga 1.3 liter standard 80. This current model is the third generation of Proton Saga, which was start manufactured at 28 September 2016. It is manufactured by the company Proton Holdings Berhad, which is an automotive company active in automobile designing, manufacturing, sales, and distribution. So the technical specifications for Proton Saga is separated into four main parts. That is engine specification, chassis specification, dimension and weight, safety and security. So for first, the engine specification, the Proton Saga 1.3 liter has a 4-cylinder inline engine with 16-valve double overhead camshaft with the variable valve timing technology. It has a displacement of 1.3 liter and 4-speed automatic transmission type. For the chassis specification is same for all the variants of Proton Saga, except for the tires and wheel, which the premium and premium S variant has 15-inch diameter. This is the specification for weight and distribution. So this is a list of technical specification for the safety and security in Proton Saga. All in the list exist except for the reverse camera and front parking sensors. The Eco-Drive Assist mode is one of the interior technical specification for Proton Saga that relates to energy efficient. The Eco-Drive mode is controlled by the ECU, which sends commands to different part of the vehicle. For example, like it sends a command to the total body valve intake to limit the combustion of fuel, resulting in saving fuel. Secondly, for automatic transmission type, shifting to a higher gear to put the car in a cruise mode, which will also resulting in saving fuel. Next, for the aircon system in a car uses a lot of energy power. So this eco mode will reduce the aircon efficiency to 70 to 80% from 100%, which will also result in less energy power usage and saving fuel. One negative trait from this eco driving mode is the uncomfortable driving experience due to the limitations the eco mode provides. That is all for my part. Thank you.
Good evening, my name is Shogun Ram Gopalakrishnan. My metric number is MH19054. Today I'm going to present about ways to produce energy efficient vehicle. We got several ways to increase our energy efficient vehicle, and all of that is using energy under braking, using basically energy additional supply by solar cells that we frequently use nowadays, improve the mechanical energy transmission system, improve car shell design, increasing of efficiency of power converter, special design of electric engines that make the engine more efficient, route selection of the criterion of minimum consumption in real time, and the last one is the parameter monitoring inside and outside of the vehicle, and computerized system control the optimization of energy consumption. Next, we'll see the one of the main topics, electrical losses reduction in EV. Energy efficiency of the electric motor. One of the main scope to extend the ideal working range for each speed and each load torque of the specific work area. The second is the optimization procedure that lasts as little time as possible to have the least amount of the sensor necessary to be as simple to address as others. Next, we will see the difference between supercapacitor and accumulator battery in full sense. For supercapacitor, they are characterized by the electrochemical double layer phenomenon, diffusion, and huge effective area and ability to charge. Electrochemical capacitor can be used to enhance the performance of batteries when specific power is taken into account. And the supercapacitor provides a substantially higher capacities and specific energies that regular type of capacitor. And for the accumulator, the example of the low specific power device, where the conventional capacitor may have a specific power greater than 1 mA, but at a very low specific energy. When it combined with the battery, electrochemical capacitor can improve their specific power characteristics and capacitor properties in terms of specific energy. There are several topics under the mechanical losses reduction in EV. First, a role of tire is playing a main role. There's a large range of development and research with tire optimization is done using energy efficient criteria. The average car with a good tire could do well, but the one with a bad tire, even the best car did not stand a chance. So the racing tire is made of very soft rubber compound that provide the best possible grip against the texture of the racetrack, but way out quickly. And the next, we think we can go with the vehicle body. Vehicle body is automotive design, particularly the design of the electric and hybrid electric vehicle, that present a number of challenges that must be addressed by an appropriate design environment. Next, we say aerodynamics of the EV is also playing a main role. Movable aerodynamic components are nothing new. Every time you see it on a headliner, you can see the wing flap and ailerons moving around the system. And for example, Formula 1 racing car all work in the same way. Drag reduction system is a new tool available to racing driver, DRS, we call it DRS. It is actually a receptacle rear wing that can be used to aid in the overtaking. And the last one is the solar cells that nowadays we use it frequently in our industry, automotive industry, and they several automobile manufacturers intend to install solar panel in their new hybrid vehicle to save the energy, save the energy efficient. Constant technology advancement will improve the condition for the option in the coming years. So the roof panel nowadays powers at least a portion of the hybrid. And last one is single and multi-transparent silicon wafer are used in the most common type of solar panel. So these are several ways to increase the energy efficient. And thank you. That's all from me.